Good morning. My name is Parani Surendran and my student ID is B091910212. In this glory day, our group going to present about the torsional loading evaluation from actual structure. Introduction. Torsional loading is a test that fits a material or test component to a specific degree with a specified force or until the material fails in torsion. The twisting force of torsion test is applied. The rotating moment may also be applied to both ends of the sample, but the ends must be rotated in opposite direction. The objectives. The first point is to determine the behavior of a material or test samples exhibits when twisted or under torsional forces. The second is to determine the modulus of elasticity in shear, yield shear strength, torsional fatigue life, ductility, ultimate shear strength, and modulus of rupture in shear. The final point is check the product quality and design and ensure that it was manufactured correctly. Thank you.
Very good morning guys, my name is Mama Maradi Mejazmi and now I would like to present you about the product and model. So what we have here is a wrench cross, or another name is leg wrench. So from this product what we use is steel as a material, and this steel has a 80 gigapascal shear modulus. Okay, from F1 to the middle, the length is 0.23 meter, and also same from middle point to the F2. We also got a diameter is 0.012 meter, and the radius is 0.006 meter. For the force, from the F1 and F2, they have a same force, which are 80 Newton, because the length from F1 to the middle and F2 to the middle are same. So I would like to show you the video how to use this product. Okay guys, that's all for me. I would like to proceed to my friend for the next presentation. So thank you, see you again.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahir bin Ma'ruf and I will explain about calculation. So first of all, we have to find the equation of equilibrium, which is total Fx equal to 0, total Fy equal to 0, and moment equal to 0. For the Fx equal to 0, there is no force on the x-axis. For the Fy equal to 0, F1 minus F2 equal to 0. F2 is negative because we assume the force is going downward. So F1 minus 80 Newton equal to 0, and we will get F1 equal to 80 Newton. For the moment equal to 0, 80 Newton, which is F1, times 0.23, which is length 1, plus 80 Newton, which is force 2, times 0.23, which is length 2, minus T equal to 0, and we will get T equal to 36.8 Newton meter. And then we have to find the shear stress, which is tau. So first of all, we have to find the polar moment of inertia. The formula is J equal to pi over 2 times R power of 4 pi over 2 times radius, which is 0.006 power of 4, and we will get 2.04 times 10 power of negative 9 meter. And then we have to find the tau allow, which is, the formula is Tc over J. T is what we get from the equation of equilibrium, and C is radius over J is polar moment of inertia. So 36.8 times 0.006 over 2.04 times 10 power of negative 9 meter, and we will get 108.24 megapascal. And then we have to find internal tau, 36.8 plus 0.23 times 80, and we will get 55.2 Newton. And then we will find the tau max. The formula is Tc over J. T we get from the internal tau, C is the radius, and J is the polar moment of inertia. And then we will get 55.2 times 0.006 over 2.04 times 10 power of negative 9 meter, and we will get 162.35 megapascal. And then we have to find the angle of twist, which is TL over JG. So 36.8 times 0.23 over 2.04 times 10 power of negative 9 times 80 times 10 power of negative 9, and we will get 0.052 radian. And then we have to convert it to degree. So 0.052 times 180 degree over pi, and we will get 2.98 degree. And then for the factor of safety, the formula is tau max over tau allow. Tau max is 162.35 times 10 power of 6 over tau allow, which is 108.24 times 10 power of 6, and we will get 1.500. It is between 1.3 and 1.5 factor of safety for use with highly reliable materials where loading and environmental conditions are not severe, and where weight is an important consideration.
Hello, I am Muhammad Hizat Misaleh from 2Bmmm, and now I will explain more about the discussion. Cost range is our choice of tools. It consists of 4 N, and each N have different size. This tool will make our life easier because it has 4 options of nut size. This tool is also one of the way to cut costs because it has different size. The cross design will also act as a handle when you are using the wrench. When the force is applied to unscrew a nut, there is a torsion force exists. Torsion is the twisting of an object due to an applied torque. Polar moment of inertia is a shaft or beam's resistance to being distorted by torsion as a function of its shape. For the polar moment of inertia, as we calculated, the result that we got is 2.04 times 10 to the power negative 10 m4 to the power of m4. For the factor of safety, the FOS, by using the formula strength divided by stress, the number that we got is 1500. This number concludes that this cross range is safe to use, but can also differ due to certain reasons, just like what material that been used in this tool, the amount of torque applied, diameter of each rods, and what kind of force being used. The last part of this project is the conclusion. to conclude this project, there are many things that we can throughout this project. For example, we know more about torsion and torque. In torsion, also involve the angle of twist. We also apply our knowledge on how to calculate torque, torsion, stress, and maximum yield stress. Other than that, we also know that each object has maximum stress allowed. In conclusion, we know that torsion test is used to determine the behavior of a material when going under torsional force that cause shear stress to the object. This is all from us. Thank you.